In ionic solids, the coordination number Cn and geometry of crystal depends upon the radius ratio. Okay, radius ratio, radius ratio. It is defined as the ratio of the radius cation to that of anion. It is defined as the ratio of radius cation to that of anion. Cation to that of anion. Okay. Radius ratio equal to radius of cation whole upon radius of anion. That is Rc upon Ra. That is R positive upon R negative ion. This is the radius ratio. Okay. Hence, the ratio of radii of positive and negative ions is called the radius ratio. The effect of radius ratio in depending the coordination numbers and shape of an ionic solid is called as the radius ratio effect. The effect of radius ratio effect. Okay, radius ratio effect. The effect of a radius ratio in determining the effect of radius ratio in determining the effect of radius ratio in determining the coordination number, determining the coordination number and shape of an ionic solid is called as radius ratio effect. Okay. The radius ratio effect. The effect of radius ratio in determining the coordination number and shape of an ionic solid is called as radius ratio effect. The effect of radius ratio in determining the coordination number and shape of an ionic solid is called as radius ratio effect. The effect of radius ratio in determining the coordination number and shape of an ionic solid is called as radius ratio effect. Okay. Thus, radius ratio is used to predict the shape and arrangement of different ions of the ionic crystal. The limiting radius ratio value for various coordination number and the corresponding structure are given. You can show also this table limiting radius, limiting radius ratios and structure and structure. Okay, radius ratio. R positive ion upon R negative ion. Coordination number. Coordination number. Cn. Shape of crystal. Shape of crystal. And example. Okay, radius ratio is less than 0.155. Then coordination number 2, and shape of the crystal is linear. Okay, and second 0.155 to 0.225. This is the radius ratio number. Then coordination number 3. Coordination number 3, and shape of the crystal plane triangular. Plane triangular, and example boron oxide. Next is 0.225 to 0.414. That is coordination number is 4, and structure is tetrahedral. Example zinc sulfide, ZnS. Next is 0.414 to 0.732, and coordination number 4. Shape of crystal is a square planar. Okay. Next is 0.414 to 0.732. Coordination number 6, and structure is octahedral. Structure is octahedral, and example NaCl, sodium chloride. Next is 0.732 to 0.999. Coordination number 8, and shape of crystal body-centered cubic. And structure CSCl. Okay, and radius ratio if 1, then coordination number is 12, and structure is close packing. Okay, structure is close packing, and example metals. Okay, the structure of metals is close packing. Coordination number 3468. Coordination number 3468. 3468 are common. The appropriate limiting radius can be worked by the simple geometry and their corresponding shapes may be predicted. If the ionic radii are known, the radius ratio can be calculated, thus the coordination number and shape may be predicted. Shape may be predicted. The simple concept of radius ratio predicts the correct structure of ion solids in so many cases. The coordination number of 5, 7, 9, 10. Coordination number 5, 7, 9 and 10. The coordination number 5, 7, 9, 10 and 11 do not occur in crystals because in these coordination numbers geometries do not pack closely as various positions are occupied by kernels in metals. In metals, radius ratio is exactly equal to 1. Next, studying radius ratio and stability of ionic crystals.